What's up everyone, welcome to the third tutorial in our Pandas course. This will be our first exposure to Pandas series, and we're just going to learn a few techniques we can use to create Pandas series from data. We'll learn how to create series from Python lists, then we'll learn how to create series from dictionaries, and finally we'll work with NumPy arrays and series and the conversions back and forth between the two. Now that last one will assume that you have access to NumPy. If you're using Google Colab, then you absolutely do. It's already in the system. If not, then make sure you install it beforehand and then you can import it. At this point, if you've taken this tutorial, I assume that you know how to use NumPy anyway. So let's head on over to Google Colab. Alright, so the very first thing we might want to do is import NumPy. I'm just going to import NumPy as NP. Okay, we'll go ahead and run that cell, and that should give us access to NumPy and Pandas. By the way, mine's a bit zoomed in. I find if I zoom in too much, as much as I'd like to do that so you can view it more easily, the kind of tooltips that come up end up blocking a lot of the code, so that's why it's a bit more zoomed in, but not quite as zoomed in as I would like. Also, just a quick side note. If you are using Google Colab and you step away for a while and come back to it, sometimes it kind of shuts down the kernel and you have to restart it. If that happens, just make sure you run your import statements again. In fact, it would maybe be a good idea to run your import statements every time you start up a new cell. That will ensure that you have these. Okay, we'll kind of write the code so that each cell is independent of the last, except for this one, of course. Okay, so make sure you have that, and we'll go ahead and start up a new cell there. So don't worry too much about the run numbers there. This is run 15, even though it's probably only run 1 or 2 for you. Let's just make sure that they're in order. Okay, so the simplest way to create a series is going to be through a Python list. We can enter whatever kind of data we want. We can do maybe integers or floats. We can also do booleans and strings, although in Pandas, strings are considered to be an object type. There really isn't a string type, they're just default to objects. Also, we can enter in none. That's kind of like null if you're coming from other languages. And we can also enter np.notAnumber. We can also do pandas.notAnumber. So it'll look a bit like this, np.nan. You should get used to seeing this because you'll be seeing it a lot. What this represents is some sort of data that is basically there's an attempt to convert it to a number, but for whatever reason, it just could not be converted. Let's say you're reading a CSV and there's like a true or false value in there and it tries to read that as a number. Well, it's probably going to give you np.nan or some kind of not a number value, so you should learn how to deal with that, and don't worry, we'll cover all those cases. Okay, so getting to the actual code, we'll just create a variable called series. It's going to be a pandas, actually equal to a pandas series, like so. Okay, so you can see the parameters. Data is going to be the most important one. That is going to basically take in whatever values we want. We can add specific indexes. These are going to be kind of labels for the indices. Otherwise, it defaults to just the position, so 0, 1, 2, etc. We can assign a specific data type. Otherwise, it interprets it automatically. We can provide a string name if we want, but we probably won't. And then copy and fast path we'll kind of ignore. You can explore some more information there. For now, what we'll do is just pass in some values. I'll just do like 1, 2, and 3 or something. Okay, we can go ahead and print out series if we want, or we can just run the cell and just display series, but we'll use these print statements where possible, because if you're not running in Google Colab, then you'll need these to actually view anything. Okay, cool. So if we run that, we can see that we get everything listed, interestingly enough, top to bottom. We get the data type of int64 that defaults because we're using integers. Okay, we can see that we get the indices 0, 1, and 2 because there are 3 elements here, and then we get the values here. So we can mix this up. Let's say we want like 4, 5, and 6. Maybe that will be a little clearer. You can see clearly the indices and then the values here. Okay, we can also do floats. Okay, it will look very, very similar. Let's say we want 4.0, 5.0, 6.0, and you know what, let's add another one just for fun, for variety's sake. We can rerun that. You can see that these are decimal numbers now, and then we get the float 64 as the data type. So it automatically changes depending on the kind of variable that we're using, or rather the kind of values. We can also have booleans. So let's say we want true, false, true or something. Okay, and that's kind of annoying. That's why I was zoomed out a bit there. And then we want to go ahead and print that. You see that we get the data type bool. And then finally strings. Let's just enter in some string numbers. We'll just do like 1, 2, and then 3 or something. Okay, you can see 1, 2, 3 values. They even look like the integer representations, but clearly the data type is an object. So again, no string data type, it just defaults to an object. Now, Pandas does an interesting thing when it's creating these series and assigning the data type. Essentially, it assigns the highest level representation that it can find. So what I mean by that is, let's say we have a series that looks a bit like this. So we have a Pandas series, okay, and we have some, okay, that's kind of annoying, we have some values that are like 1, 2, then we have like a 3.0, 4.0, and then we have some strings in there. So let's say we have, I don't know, a name, something like that, okay? What do you think the data type will be here? Well, because it's taking the highest level representation, it will actually default this data type to an object. Okay? And that's because it knows that it can convert all of these to an object, but it cannot convert this necessarily to a number. Okay? If this wasn't there, then it would convert it to a float. And if the floats weren't there, it would convert it to integer. Okay, so if you're guessing kind of unexpected data types, it may be because your data is, let's say, corrupt, or it might just have some values that you weren't expecting. Also, I talked about the none values and the np.nan. We could do something like this, series equal to pd.series. Okay, and let's say we have some numbers here, 1, maybe like 3.0, and then we have maybe some none values. Again, this is kind of like null. This is basically saying there's supposed to be some value there, but right now there isn't. And then we can have np.nan. You can also do pandas.not a number, but for some reason people seem to like NumPy not a number a little better. So again, this is basically just saying that we have some value that we tried to convert to a number, but it came out as, you know, something that was unexpected. Okay, so you can see that we get not a number and not a number. So even though we entered none, because we're dealing with floats, it defaulted to not a number. However, as soon as we throw in a string there, actually, you know what, I'll just do this and I'll add in a string because I would like to separate out the two. Just, you know, add in my name or something. As soon as we add that in there, you can see that the type changes to an object, and we keep the NaN here, but now we get none. Okay, and that's because it's taking essentially the string representation of that. And just a sec, just to make sure that we include everything that we went over, I'm just going to do this. So I know this is a lot to take in. Don't worry, we will be adding comments to each of these lines of code, or if I think that you understand it just fine, I won't add the comment, but I will be commenting a lot of these lines of code. And of course, this source code will be included with the rest of the files for your reference. Good idea to follow along, even if you do have that source code handy though. Okay, so the other thing I wanted to cover, especially when it comes to data types, is that you can explicitly assign a data type. So far we've been using the kind of implicit interpretation, but let's say we have a bunch of integer values, but we want this to be an array of floats. Okay, so we can do our series is equal to pandas series. Just going to enter in some integer values. Let's do 1, 2, and 3. But let's say we want this to be floats. Okay, so we can do a data type parameter. Okay, and then we can enter whatever data type we want. So for example, let's say we want these to be float 32s. Okay, we don't want to use up too much memory, but we might be dealing with large numbers. So we can run that, and you can see that not only has it converted these to decimals, but the data type is now float 32. You can also enter in string values, or rather a string representation of this float word, or you can use whatever data type you want. A common representation might be converting these to objects. If you have a bunch of numbers, but you want them to be objects, that would be a fast way to do so. Alright, so I'm actually going to give you guys a bit of a break because I'm trying not to do super long, like 20-minute sections. So I'm going to leave you with this. What I would recommend you do is you practice this up a little bit, try to come up with some examples of homogeneous pandas series, that means all just one data type. Try some heterogeneous series, that means multiple data types. Work with some ints, floats, booleans, and objects. Remember, we want to think about these as objects rather than just strings, as well as nuns and np.nan. When you're super comfortable with that, we can move on to the next section. When we come back, we'll still be working on creating series, but we'll be taking a look at creating series from dictionaries, as well as explicitly assigning indices and finishing up with NumPy arrays. Okay, so stay tuned for that. Thanks for watching. See you guys in the next one. Hey guys, welcome to the fourth tutorial in our Pandas course. This is the second part of our Pandas series. In the previous section, we covered how to create series from Python lists. Here we're going to go one step further and learn to create series from dictionaries. This will give us a chance to explicitly assign the index labels of our series. And also we'll learn to create series from NumPy arrays. That's actually really easy to do. So let's head on back to Google Colab. Alright, so this is where we left off last time, 3a. So you can see I added the labels and everything. We just explored a variety of techniques we can use to create a Pandas series from Python lists. Also, again, make sure that you are watching the kinds of data, or the types of data that are going into these, because those will determine the overall data type of the series and all of the values within it. Okay, so now we're going to get started with a new cell, and we'll continue on here. Alright, so the very first thing we want to do is create a series from a dictionary. So these are going to be basically key value pairs. You should be fairly familiar with Python dictionaries. They look like this. We're just going to use string keys and then numerical values, although again there's no real limit as to what you can do with there. You can have any kind of value you want. They can be floats, ints, they can be booleans, they can be strings, whatever you want. So we'll start by, again, creating just a series. I think we'll stick with that nomenclature. And we're just going to set this equal to a pandas series like this. And instead of the array, or the list rather, we're going to explicitly enter a dictionary here. So I'm just going to maybe do the A, B, and C labels. That way we have a bit of variety rather than just 0, 1, and 2. Again, these are the automatic implicit labels that it assigns. Those are just based on position. So we'll just do, I don't know, we'll do A of 1, do B of 2, and then we'll do C of 3. So fairly straightforward here. Let's just put that there. Okay, and then we're just going to go ahead and print out the series so we can see what it looks like. Okay, cool. So very similar to before, we have integer values, and they're all integers. So it will default to int64. You can see the values there, but now the labels have changed. So the positions are still there, absolutely. This is still index 0, index 1, and index 2, but rather than using those indexes as labels, we have explicitly assigned different labels. So now we can access things based on position, so 0, 1, and 2 again, or we can access things based on the label that we've chosen. Okay, this is just a nice way of kind of making your series as explicit as possible. So again, there's nothing wrong with using just the regular indexing labels. That's totally fine. But if you want something that's a bit more descriptive, then this might be a way to go. So just like before, just to kind of demonstrate, we can also have floats, booleans, or strings as the values. I'm just going to create some more series and show you guys. We could do like true, false, and false. Okay, that is totally allowed as well. And those are going to be the boolean data types. We can do some floats instead, 1.0, we can do like 2.0 and then 3.0, and those are going to default to floats. Actually, interestingly enough, let's just do np.nan just to show you guys. That actually should default to a float 64 as well, just because the NumPy, not a number, is for whatever reason interpreted as a float 64. So that's kind of just what it defaults to. Also, we could do strings. So let's say we want to do the string representation of 1, string representation of 2. Oh, actually, just make sure you don't get rid of that comma there. Okay, and then the string representation of 3. And that's totally fine, but remember, strings are considered to be objects in Pandas. Okay, so this is cool. Can we do the same thing, that is assigning these explicit labels, but with a list? Absolutely we can, and that's why there's the index parameter when we're creating series. So we could do something like this. Series is equal to a pandas series. Okay, and we're just going to enter in some data. It's going to stick with some integers for now. So 1, 2, and 3. And we can also pass in, actually that's kind of annoying and blocking it, we can also pass in the index parameter. So when we're passing in the index, we have to explicitly assign the labels that we want. Now, it's important to note that we have to enter the same number of labels as data points that we have. So, whereas we could do something like this, A, B, and C, and note how it's just a list of values, this is totally allowed. Okay, good result. We can't then do something like this, D. Okay, and that's because now these are two different lengths. Similarly, I couldn't do, let's say, 4 here, but only 3 values as my index. Okay, I have to make sure that these are both of the same length. All right. Other than that, it doesn't really matter what labels you choose for these. Obviously, you'll want to pick something that kind of makes sense, because the whole point of assigning the labels in the first place is that you're being very explicit with what the data is representing. Okay, so we can go ahead and run that, and that is fine. Also, these again could be strings, floats, booleans, objects, doesn't really matter. All right, now one of the final things I wanted to show you before moving on to NumPy is that we can actually use a scalar value that is a single value, and we can populate that throughout the entire series just using that single value and then the indexes that we want. So let's say we want to do something like this. We do series equal to pandas series again. Okay, and we're actually not going to pass in a list of values like before. We're just going to pass in the value 10. So let's say we want this value 10 at 5 times in our series. So essentially we just want 5 10s in our series. Okay, we can do something like this. We can just assign the index equal to a list of numbers. Make sure we have 5 of them, so 0 through 4. And that will create 5 10s. So essentially it just creates these indexes, creates a series with these indexes, and assigns this value to every single one. Similarly, we can do string indexes if we want. So we can actually do something. I'm just going to copy this to save some time. Okay, we can do D and E as well. And that will do exactly the same thing, just with the different labels there. Okay, so this is going to be super useful if you want the same value many, many times. You could maybe create a list through a loop. If you wanted, let's say, like 100 times, it'd be really annoying to do that all by hand. But there you go. That way you can kind of create a series with all of the same value as many times as you want. Okay, and now the final thing I wanted to do is talk about NumPy series, NumPy arrays rather, conversing back and forth between NumPy arrays and Pandas series. Again, the conversion's super simple because these two data structures are actually pretty similar in terms of what they can do, their functionality, how the data is represented, and so on and so forth. The main difference, I would say, is that Pandas series are strictly one-dimensional, whereas NumPy arrays can be multi-dimensional. Okay, so just going to make a quick side note, a quick comment here. It's going to be NumPy stuff. Okay, so let's say we want to create a series. Again, Pandas series. And again, we're just going to work with numbers. I think for the most part, we'll be working with numbers. I find most of the calculations just make sense, although I'll demonstrate where appropriate that we can do a lot of the same stuff with strings, or in this case, objects and booleans. Okay, so instead of entering some values in, we're actually going to enter in a NumPy array. So NumPy arrays are created fairly similarly. We can just populate it with a Python list. But we're creating the array, and then we're using that as input into our series. So now if we print out the series as the same series as before, we got 1, 2, 3. The indices are 0, 1, and 2, and the data type is int64. So it actually doesn't say anything about the type being NumPy ints or anything like that. It just knows exactly what to do because, again, there's this really great kind of synergy between NumPy and Pandas. But the whole point here is that we should be able to convert back and forth between the two. And that's actually pretty simple to do. We can do, let's say, like NumPy series is going to be equal to series dot to NumPy. Okay? And then we can go ahead and print that out. So it will look exact. Oh, actually, this is still printing out series. That's probably why. So let's do that. Okay, so now you can see that's obviously printing very differently. It's printing exactly as a NumPy array would. In fact, if we wanted to check the types of these, we can do so. We can just print out maybe the type of series. Okay, then we can also print out the type of the NumPy array. In this case, it's actually called NumPy series. Okay, there we go. Okay, so we can see that the first one is a series, and the second is a NumPy ND array. Okay, and you can also see that, again, we're using the NumPy printing format rather than the Pandas format. There's another way we can do this using a NumPy function rather than a Pandas function, because this is part of the Pandas library, but we can do something like this. We could do, let's say, NumPy series is going to be equal to np.asArray, like this, and then we're just going to pass in the series. So it should do pretty much exactly the same thing. It's just, again, using a NumPy function instead of the Pandas function, but the end result is exactly the same. Okay, so that is pretty much all we wanted to cover. There's a lot of different ways that you can create series. We covered just basic lists, various types, and then we covered dictionaries, and then using lists and explicit indexes, and finished up with NumPy arrays. So again, play around with this, make sure you're super comfortable with this moving forwards. Once you're ready to move on, the next section will be all about dates. That will be covering the pandas date time type as well as date ranges. So stay tuned for that. Thanks for watching. See you guys in the next one.